we now look at an example of solving an inequality where we want to use the principle we established in just before. Now, there are many ways of solving such inequalities. You could look at them graphically and in other ways. What I want to do here is solve them sort of purely formally using the principles I've just previously established. So the first thing to notice about these two terms is that the term on the left is not defined for x equals 3 and the term on the right is not defined for x equals 1. So we need to sort of exclude those in the first step. So for all x different from 3 and different from 1, we have, and now we start working with these terms. So we want to isolate x here by applying operations to these terms on both sides of the inequality. I notice that I have x in the denominator here on the left-hand side, which is not very useful. So what I would like to do is apply the function 1 over x to both sides. In other words, take the reciprocal of both of these fractions on both sides. So I want to apply the function x goes to 1 over x. So let's just do this and then think about whether we are allowed to do that. So according to our principles that we discussed before, we can do this without changing the symbol if the function is strictly increasing, and we need to change the symbol if it's strictly decreasing. So we're applying the function f that takes x to 1 over x. This function looks roughly like this, and you see the function is strictly decreasing on its domain, and its domain is all x except x equals 0. So first of all, we need, since the function is strictly decreasing, we need to switch around the inequality symbol, but we also need to be careful about 0. In other words, when we apply this function, we need to make sure that it's defined for the term. The term on the left can never be 0, the term on the right can, because the numerator is an x, and so we need to look at what happens at x equals 0. At x equals 0, well, let's plug it in. I get 2/3 on the left and I get 0 on the right, and 2/3 is indeed greater than 0. So that means x equals 0 is a solution. Whereas if we look at this term, x is here in the denominator and we lost that solution. So we need to sort of artificially add it on. What about, so this allows us to include this implication. What about going upwards? Well, it's the same thing. We apply the same function. Going from here to there is also applying the reciprocal function, which is, well, this function is decreasing. We have switched around the inequality symbol, so no problem. And the denominators here we have considered separately, and the denominators here we have taken care of up there, so we can really reverse the symbol. Okay, so that's all fine. Now, what's the next step? Well, next step would be here to get rid of this denominator, which I can do by multiplying both sides by 2. So, and multiplying by 2 is an increasing function. There's no problem. This would end up here on the right with 2x minus 2 over x, right? In the next step, I would want now to multiply by x in order to get rid of this denominator. Now, I do not know whether x is positive or negative. It could be either. So I need to distinguish two cases, right? If x is negative, then multiplying by x is a decreasing function, and I need to switch around the symbol. Whereas if x is positive, I can do it without changing the inequality symbol. So, and I need to make sure that I take care of that. So here I forgot to carry along the extra solution x equals 0. So the next step, I want to now multiply by x, but I need to distinguish between two cases. For case 1, x is positive. Then I can multiply by x without changing anything, and I get 3x minus x squared less than 2x minus 2. Or x is negative, if I multiply by x10, I need to change the symbol around. And we'll carry along the extra solution x equals 0. All right, so we have 3 parts here, and we can work with each part separately. So on the side here, I'm just going to look at this term here, which appears here as well. So to solve this inequality, we'll look on the side. So let's take this one, 3x minus x squared less than 2x minus 2. I'll just put everything on one side. In this case, I'll decide to put it on the right, which is just adding or subtracting terms, which there's no need for changing the inequality symbol. So I get x squared minus x minus 2. And luckily, the right-hand side here factorizes into x minus 1, actually x plus 1 times x minus 2. And I forgot my ifs and only ifs, which are important. The function on the right, the term on the right, I look at as a function. It's a quadratic function whose graph is a parabola with roots at x equal -1 and at x equal 2. So that's where it crosses the x-axis. So it's a parabola roughly looking like that. All right, so these points are important because they determine whether the function is positive or negative. So, so the function here is positive, greater than 0 for x equal -1 or x greater than 2. And it's here I will need the symbol. I will get the symbol the other way around. So the function is negative here between -1 and 2. So I'm going to translate the information I got through graphing this function into these solutions here. So here I'm looking only at x's which are positive. So I'm asking myself, for which positive x is this function positive? And that's for the ones for x greater than 2. So the first brackets just translate into x bigger than 2. The second one, here I look at negative x's. I just look here at the negative side, and I'm looking for x's where this function is negative. So you see this happens between -1 and 0. So -1 less than x, less than 0. And again, I'm carrying along x equal to 0. In the last step, you see what I can do is I could add on this extra solution to this inequality. So I have, this is the case, if and only if x is greater than 2 or -1 is less than x, less than or equal to 0. So maybe we should, in the final step, we should write down, summarize what we have found out. So the solution. So the original problem was find all x's for which this inequality is true. We excluded here x equals 3 and x equal 1. So we'll write down that this inequality holds for all x with x different from 3, right? X different from 1 is not included in any of these, so it's excluded anyway. X different from 3 and x bigger than 2, and really to be or -1 less than x less or equal to 0. Okay, and that solves our inequality just using the principles of decreasing and increasing functions.